welcome developer advocate from Google, Nano Mars.
Hi. Welcome to DevFest 2010, and thank you so much for coming out and giving some of your time to us, and hopefully we can give you back something in return. My talk today, if I can get my slides up, is on mobile mapping. So I wanted to talk for a minute before I got into the meat of it. I wanted to talk for a moment about why we care. This is a Nexus 1. It's an Android device. That's Google started selling it recently in the States. It's an unlocked developer device. But why do we care about it? Is it just because we're selling phones? Is it just because we think that phones are cool? Well, the truth is, for most people in the world, this or some device that looks like this or is about this size is their primary computer. They may not have access to a laptop or a desktop or any of the other things that we become very used to. And here in Japan, this is already true for a lot of people. This is a primary communication device. In the States, we're still getting used to that idea, but we're getting there very fast. And these devices are becoming incredibly powerful. I have actually on here. How many of you have watched Star Trek? Anybody watch Star Trek? No? Okay. Maybe I'm too old. Star Trek was an old space movie, a space TV show. And I'm old enough to remember when it was actually first on. But this, I have on here my ringtone from this, is the Star Trek communicator sound. Because these things are now more powerful than the Star Trek communicators were. You can do more with this than you could do with those devices. Except I can't call a spaceship and have it beam me up. So these devices are becoming rapidly, extraordinarily popular, valuable, and important to the way that we live in this world. And they come with potentially a host of services: geolocation, compass, accelerometers. They come with They come with phones. They come with network connections. They come with who knows what other features are going to be on here. Cameras, maps, etc. And fundamentally, the difference between this and this is you take this with you wherever you go. Now, some of us, like me, take the laptop with us wherever we go too. But this thing, I mean, if it's in your pocket, it's meant to be carried everywhere. This thing, this thing hurts my back. So it's fundamentally about what's around you, and what is more fundamental to that than mapping, right? Placing things on the map is really fundamental to these devices, showing you what's around you, showing you lists of things, showing you maps of things, showing you how to get from one place to another. So I'm very excited by this and mobile mapping. As soon as we started releasing Android phones, I started to talk to people about how do we deal with the whole mapping issue, and how do we get developers more able to share maps with each other, share maps with the world, share maps in their applications. So that's what I'm going to be talking about. All right. So enough of the inspirational stuff. I want to talk though about this. This is sort of a spectrum of devices. Have here on the end, and I just chose something at random, but a Nokia device. It's got Google Maps on it, but it's a lower end device. It's got not a fully capable browser. It doesn't have a native API. There's your options for developing on it are are not very great, but I'm going to talk about that. In the middle here, you've got another type of development that you can do on phones. These are smartphones. These are the Android and iPhone devices. They have native Google Maps APIs. So you can develop, if you're developing an iPhone application, using the native APIs, using the code base, the software development kits in those applications, you can put a map into your application, both in Android and iPhone. And on here, I want to talk about, the other thing I want to talk about is browser, is the browser. HTML5 and powerful browsers on smartphones, that's where we see the future. That's where we see easy application developments, easy use of HTML5 features, and powerful reuse of applications across platforms. Okay, so that's the spectrum. So I want to talk a little bit about what makes mobile application development different. One big thing is the screen size. This is a lot smaller than that, and it's a heck of a lot smaller than this. So your map on here has to fit well, and that means that the controls that are on the map have to adjust to the size of the screen. And you have to think a lot about what you actually put onto your map. It's very important. The thing I'm going to talk most about today is latency. Latency is how long your app starts to get started, how long before somebody actually sees a map and is able to do something useful. There's other things you have to think about, user interface and interaction, how people interact with the map, whether they can pinch or double-click to zoom, or how that happens. That's different than happens on the desktop. Speed of integration with your other services on the device, other location-based services, and other services that the device might provide. Okay, so I'm going to talk now for a while about latency. And there's two kinds of latency. There is the time it actually takes to load your entire application before somebody can actually start to interact with it. And then there is the user perceived latency. That is the time it takes before the user actually sees something, what the user thinks about this. And I think the second point is actually more critical than the first, right? Whether or not somebody can actually interact with it, their perception of your application is going to be based in the first few seconds. Somebody clicks on the map, or they click on the application that loads the map. If it's taking 20 seconds, 30 seconds to load, they're going to go to somebody else's application very quickly. So, user perception, and also the actual speed of the application. What's on my next slide? So these are some of the things that cause this, that cause latency in applications. So one is the serving of the data. That's something that's in your control as a developer. That's your servers. That's how you get the data to the device. That's up to you. Then the download time, bandwidth versus latency. You could download lots of files at once, but they may take a long time to get to the actual device. So that's up to actually the network provider, right? So I don't know any of you, maybe some of you are network providers, maybe some of you aren't, but this is another thing that if you're a developer who's developing an Android application or an iPhone application, it's probably out of your control unless you are working actually for one of the providers. 3G networks have reasonably high bandwidth and low latency, but other networks don't. 2G, most of the world is still on, well, actually most of the world doesn't have data connection, but most of the world that you're going to be developing for will have 2G. Loading a small file and a big file over a 3G network takes surprisingly about the same amount of time. So you want to load as few files as possible. You do want to compact the size because it'll help, but primarily you want to be loading as few files as possible at any one point. And then the last point is JavaScript parsing time. That's under our control. And actually a bit of this, this second point here under bandwidth and latency, the actual files that you load, that's under our control as well. And I'm going to talk a little bit more about that later when I talk about Maps API version 3. Okay, so I mentioned the browser, and I want to talk a bit more about some browser advantages. So developing a map for your browser. How many of you have developed a Google Maps API or Yahoo Maps API, something like that? Okay, a fair number of you. So it's pretty basic. You've probably, everybody's seen a map embedded in somebody else's site. It's a very easy thing to do, and to get something fairly basic up and running, and it runs on many different platforms. You've got a Mac, you've got a PC, you've got a Linux box, and now if you have this phone, if you have a phone that has full JavaScript support, it'll run on that, and you as the developer, you might need to take some account of things like screen size or something like that, but you don't really have to think, is this going to work on a Mac? Is this going to work on a PC? We've kind of gotten past most of those browser issues, with the exception of some problems with Internet Explorer. But those are relatively minor. And what you can do when you're developing a browser-based application is you can let the API provider, that's us, solve those cross-device problems for you. You also have an advantage that you don't have to have an application download to do a browser-based one. Just have somebody surf to your application. Now, the reason that this is good is if you're developing an iPhone or an Android application, they actually have to go through an approval process. So that means that anytime you want your application downloaded, somebody else has to say yes, and some app stores take a lot longer to get that approval than others. And in addition to that, it requires that somebody find the application in the App Store and download it. So there's a discovery process that's also challenging. And finally, just on that point, if you make any revisions to it, to the web version, it's there automatically. As soon as they refresh the page, they go back to the page, the map is changed. Whereas if you make it a revision and you have to upload it to the App Store, then they have to download a whole new update to their application. So this allows you to do some much faster revisions. It also allows you to take advantage of HTML5 geolocation and other HTML5 features that are coming out in modern browsers. Both the latest versions of the Android and the iPhone browsers support geolocation and increasingly support all other forms of HTML5 features that are being added. And there's a lot of HTML5 experts here. So this is I'm really excited about this, and especially in the future, this is going to be super important. So there are advantages developing using a native API. One is you get easy integration with the user interface. People are used to seeing Maps, Google Maps on the Android device and Google Maps on the iPhone. They look and feel in a particular way that's particular to that platform. And now, if you use the API, you get that for free. It's just something that comes along easy. You only have to learn one language per device. So for iPhone, it's Objective-C. For Android, it's Java. You don't have to also learn JavaScript or something else. Now, that's not an advantage over browser, because browser, you just learn JavaScript and HTML. But if you're really focused on that on a particular device, it's a good way to go. It also allows easy integration with the rest of your application. Most of the applications that show a map don't just show a map. That's not actually all that interesting. You have to put data onto the map. That makes it interesting. So easy integration with that, easy integration with other services that are on the device, like the GPS and other things. Although, as I mentioned earlier, HTML5 geolocation gives you GPS. But if you want to integrate with things like the camera, the compass, any other things, then those are things that are more easily obtained with a native API. There's also a certain amount of App Store discoverability. Most people still at this point are not searching the web on this device. They're looking through app stores to get their applications, at least in the Android and iPhone markets. There is a fair amount of web searching going on, and that's something that you can keep. You can take advantage of with a browser-based, but App Store provides another vector for people to find your application. And finally, there's lower latency. You don't have to download the JavaScript to run the Maps API because it's actually already part of the operating system. The only thing you have to download is your data. However, I will say we're getting better at that for the JavaScript API. Okay, so this is a quick summary of when to use what. And I'm probably going much slower than I usually do. So let's say we have our static maps API. This return, I'll talk a little bit more about it later, but basically use it for very low bandwidth situations and non-JavaScript browsers, which you can usually tell from user agents and other means when somebody pings you. Native app, you use it primarily when you're only developing on one platform, and it's important to have all that integration with other applications, and you see that you get a significant speed boost by going native. Browser-only version 3 Maps API applications, use those when you're developing for the iPhone and Android, and in the future for other fully JavaScript-enabled browsers. When everything is browser-based, no app is required. Now, the final one, and I'll talk a little bit more about this later, is a hybrid version. You load a Maps API version 3 application into an embedded web browser and pass it information from your device. Now, you lose some of the benefits of not having to write a Java or Objective-C application, but you get out of that a benefit of integration with your device. So your hybrid is your compromise, but I think it's a good compromise because it does allow you to take advantage of the data store on here and your compass and anything else that's on here on your device. So I normally say at this point, if there's any questions, people can feel free to ask them. I'm going through this fairly quickly. If there's anything pressing or I talk too fast, somebody please raise their hand. Okay. All right, so let me talk a little bit more about the different options. The Static Maps API returns an image. It's a simple URL. Well, okay, it's not so simple because it can be up to 2048 characters. It's actually a fairly complex URL, but in the end, all you do is a URL, and it returns a map tile. Version 2 of the Static Maps API, which we released last year, included encoded polygons, special mobile tiles, and custom icons, and a variety of other things. So it's a very exciting and very powerful way to deliver maps to a very low-end user. It does not use JavaScript, and so therefore you don't get any of the slippiness that you're used to with maps these days. It's just a plain image sits in your page. Very, very widely compatible. Okay, so for native APIs, I'm going to talk about the iPhone's MapKit and Android's MapView. The iPhone MapKit was released as part of the iPhone 3.0 SDK. It's an Apple API. That means it's not actually maintained by Google. runs under separate licensing, so you have to investigate all that yourself, and they provide the developer support for it. It's an Objective-C because everything for the iPhone is. And it's, I will say it's less powerful than the JavaScript API because that's what the features they've chosen to expose to in their SDK. But it's still pretty powerful, and it gives you the native iPhone look and feel. You get the special pins, and I think you get the special way that pins drop in. Anybody have an iPhone here? Does anybody have an iPhone? Yeah. So you know when you use the map, the pins sort of drop in from the top. I think it gives you that as well. That's pretty cool. I have a problem on my slide. It doesn't require new Android release. The iteration on the API will actually require new releases to the SDK and people downloading those to their phone, the iPhone SDK. Okay. Android development you use map view. And it's Java because that's how you develop in Android. It's got more features than the iPhone API, but still less than our JavaScript APIs. Gives you the native Android look and feel. You see on here an example of an Android map. And again, iteration requires a new Android release, a new release of the operating system. And for both iPhone and Android devices, that can mean that different devices have different versions at different times, and that can cause kind of a problem for your users. If you release something that takes advantage of new features, it may not be available to people with older phones. That's not a problem you would encounter with a browser-based. So browser only, again, these are some of the features. I've actually said most of this already. The last point is kind of important. Although you don't have the App Store approval, you also don't have App Store discoverability. So that's a trade-off. Generally, I think that this is less important than this, but it really depends on your market and how you're marketing things. Okay, so the hybrid native and JavaScript approach is the one that I like the best. Actually, I have an article up on code.google.com about how to do this for Android, and there's another one for the iPhone. You use WebView and UI WebView. So WebView is for Android, UI WebView is the iPhone SDK version of it, to load a version 3 of the Maps API page. And I'll talk about why version 3 instead of version 2 in a minute. It combines your App Store discoverability with the advantages of JavaScript. You can take advantage of multiple platforms, so you could write an Android and an iPhone application, but use just one map. So you don't have to recreate that map portion of your application for two separate applications. You can also, if you want, this is something that some people do. You actually load the HTML page. You can bundle it with your application, which can decrease the initial load of that page. It does have the problem that you're essentially you still have to maintain these two separate code bases. You just have to do a little bit less than if you were doing solely native APIs for both of them. I'll mention a couple of things. There's some open source libraries for JavaScript that mimic the look and feel of iPhone applications and Android applications. So if that's something that you care about, then this is that's an option for doing this. Again, that adds a little bit more development pain, but it's not a big deal. Okay. So now I'm going to talk about the thing that's sort of at the core of everything that we've been talking about, which is the Google Maps API version 3, and why it's a important mobile development platform. And I just realized I've been waving around my phone this whole time as I was talking, which I probably don't need to do. And particularly, I want to talk about how we attack this problem of latency. And then I'm going to do a few demos and and the fun stuff. Okay, so version 3 of the Maps API basically rewrote the entire Maps API code base. We went through and cleared out the code, reworked it, and actually changed it to a model view controller architecture, which is significantly important. We also untangled a lot of the code. So the Maps API version 2, which is what most of you are used to and what most websites you've seen have on it, something like 350,000 websites around the world have the Google Maps API. The vast majority of those are version 2. It's very powerful, but it's tangled. So for instance, a map has knowledge of markers and info windows and lots of different pieces of the JavaScript infrastructure that is used to create the API. But with the new model view controller architecture, the map doesn't need to know about a marker. The marker needs to know about the map because it needs to know where to go, but the map doesn't need to know about the marker. And that's a very significant change. It radically decreases the number of files that need to be downloaded in order to get your basic map, and the amount of code that needs to be running at any one time to get your functionality. We can very easily only delay the loading of any code that you need until it actually is necessary. So until you need to make a marker, we're not going to give you the marker code. And that's going to decrease the number of files that are downloaded in one time, and the size of the files that are downloaded. And we also combine image fetching using sprites to. So there's another thing that we do, which is that we want to address the problem of perceived latency. And so to do that, load a static map first. The API does this without you even doing anything, so you won't notice this happening, hopefully. But the first thing we want to do is show them a map so that the user sees something happening. And then behind that, in the browser, we're loading in the JavaScript code to run the JavaScript map, and then seamlessly take away the static map so you don't see it. That attacks this problem of perceived latency. Give them a map quickly. This is a comparison. It's actually a little out of date. I think we might have gotten faster, but this is basically what it takes to load a version 2 and version 3 map. And you'll see the amount of things before the amount of time before somebody actually sees a map. And this is on an iPhone on a 3G network that's got a good connection. 18 seconds. For most people, for most users, 18 seconds is too long. They will go somewhere else. Drop that down to 7 seconds, and now I think we're getting it even better. So this is the actual latency to get the Hello World application running. All right, so again, just an overview of the different pieces here. Start with a static map, use the model view controller architecture, and remove and untangle code. That's what the Maps API version 3 gives you. It's a streamlined API that is designed for use on both a desktop laptop environment and a mobile environment. Okay. So, wow, I'm actually doing pretty good with time. I'm usually at this point rushing, but I want to show you a few examples of the Maps API. I don't have great reception on my phone. The wireless network in here, my phone is not connecting to it very quickly, and I don't have something, so I can't show you this on the actual phone, but I can show you on an emulator. This is basically This is basically a version 3 map. This is the hybrid approach that I was talking about. It's a version 3 map loaded loading into the Android emulator. And I passed it a geolocation. I didn't actually use the... how many of you have developed for Android before? Okay, that's good to see a fair number of you. To pass the emulator... a geolocation is a little bit of a pain. You actually have to telnet into the emulator and pass it a specific GPS numbers. Anyway, so I just in the code I defaulted to a particular location. But this works on any Android device that has the GPS or wireless geolocation enabled. It will actually pull up the geolocation. And what I want to do is actually see if I can take a look at some of the code, see how this is going to show up on the screen. So if you're not an Android developer, this isn't an introduction to Android workshop, so I can't step through all the different pieces here. But I just want to highlight a few things that we can see here. So this is web map activity. So everything on Android that does something is an activity. And here, this URL is the URL to the web page that's actually being loaded. It's in our samples page. And here, when it creates the activity, it sets content to this layout. So this is mostly just standard Android stuff. Here I've got this get location. I'm going to show you how. This is the get location function. What I'm doing here is I wanted in this to explore how you could pass Android services, Android features on the device to a JavaScript page. So it doesn't take advantage of the HTML5 geolocation. And I did that for two reasons. One, because I thought it's cooler if I can show this. And two, because HTML5 geolocation wasn't enabled in WebView on the Android devices until Android 2.0. So the Droids and the Nexus 1s have it, but older devices don't. It's enabled in the regular browser, but not in the WebView, the embedded browser. It now is. Okay, so here, get location. Just you see this location manager. Gets the system service, and I think I need to actually scroll over here. So just pulls the location service, and then I said set accuracy, give me the best accuracy, and give me a provider. I said get the best provider. Oops. So basically I'm saying, give me the GPS and the best GPS that you have, and then give me the last known location. And when the location changes, it changes that location for the application. And then when it loads, it passes, it has this get latitude function, which grabs the latitude, and get longitude, which has the longitude, and then it passes those to, it creates this JavaScript interface that the page itself then knows about the get latitude and get longitude, and then can use that to set the center of the map. So then this is an interesting thing which was kind of new to me in this in this application development, which is that I'm creating an interface so that a JavaScript page being loaded directly into an Android application can then access directly the services. But it's only because I wrote it into this code. This isn't something that any page could take advantage of. Now, as I said, now in the 2.0 and on the iPhone version, you could use the HTML5 geolocation. But here, I'm creating a special, within my application, special access. And you could do this with things from the data store. You could do this with the compass. You could do this with a variety of other features on the Android phone. Create this interface that passes something to the page. So anyway, I thought that was really cool. So that's the emulator running it. And let's just take a look. I don't want to look at any of these. They'll be in my slides. You can look at them. I just wanted to show you a few version 3 maps that are pretty cool. This is just one. I don't know if you can see. This is actually kind of sparkling here. This is one we developed. We have a Santa tracker, so our U.S. military tracks Santa's progress on Christmas every year. It's a great way we spend our taxpayer dollars, and we help them display it on a map. And so you see here this nice little sparkly stuff that's going on. I just thought there's fun stuff you can do with the map that way, but let's look a little bit more interesting. Here you can see this is a campus map for Missouri State. And you see that they created custom overlays that overlay themselves on top of the map and create interesting effects. But this is a much nicer version here. You can see where these pins, I think, actually emulate the iPhone pins. And they created some more. This is now I'm forgetting which. This is another university campus that did a similar thing. And then you see in here, you see in here some of the info window stuff that you can do. And I also wanted to show you a static map. So this here is a static map. I'll click on this and drag it. You see there's no dragginess going on. There's no slippiness going on. This is the version 2. The Maps API uses custom icons. You can see these are little coffee icons in coffee places in New York, and that uses actually the Google Charts API to generate the icons. So I'm not a charts expert, but it uses that. So you see there, static map gives you the size, markers, and then tells you what the icons are, and that URL goes on forever, laying out the different actual locations. And then let me just check, was there anything in here that I wanted to highlight? And then you've got, services like geolocation and all that sort of thing that are very fun with version 3. Oh, and this, if you are using the default user interface, we provide now within the Maps API a default user interface. You don't have to say add in these controls. You just say use the default user interface. And it will automatically adjust based on user agents how big the screen is. So you see here, this is in a web browser. You've got all your full controls here, and these usual zoom controls there. Here you've got something that's being loaded into a browser on a phone, and you'll see it's got by default it'll just go to these smaller controls and this drop-down list instead of those long ones to help you automatically adjust your screen size. Now you have complete control over that if you want to make changes how this actually happens yourself, but if you want to rely on us to do it, we're happy to help you. The other thing that we heard from version 2, because we heard it every single day, was that keys are a pain. Any of you have developed with the Google Maps API, version 2, you put in a developer key, and then you shift your map over to another site, and it doesn't work anymore. That's because the key was, and you can just tear your hair out over it sometimes before you realize what the problem is. No more keys. Okay, so I guess I have about 5 minutes left if there are any questions, and I'm happy to talk to you afterwards. I think there's going to be some, I have some office hours. But you can learn more at code.google.com/API/maps. I'm sure these slides will be posted somewhere. Any questions? Don't be shy. No? Okay. Well, as I said, feel free to find me after my talk, and thank you all very much. I had a great time here today, and I look forward to the rest of the day.